Okay, so just now in the lesson we were looking at a question where we had a climber of weight 697 newtons who's pushing off with a force of 900 newtons at 10 degrees to the horizontal, and we're trying to find the resultant. Remember that although they were pushing downwards, the rock was pushing them back upwards that way. Okay, so the question is what the resultant, and we drew a scale diagram. From memory, the scale diagram would look something like this. So if that was, say, 60 centimetres that way, nope, 697, so let's call that 69.7 centimetres. We'd draw a line up here at 900 or 9 centimetres, and then I found the resultant to be here, which I think off the top of my head was something like 26 centimetres, I think, something along those lines. And we were finding the angle. And what I wanted to show you was a slightly easier method to do that, and it's combining everything we've been doing so far. So if I took those two vectors that we started off with and placed them like this, so that was 697 newtons, and that's going vertically downwards, and the other vector was going this way here, 900 newtons, and that was a value here of 10 degrees. I've slightly overestimated that angle, but you get the idea. Well, what we're going to do is we're going to focusing on this 900 Newton force, and we're going to split it up into its horizontal and vertical components. Okay, so if I ask you what was the height of that red arrow there, if I made that into a 90-degree corner, well, it's going to be sine, cos or tan. Which one are we going to do? Well, we got the hypotenuse, so it's not tan. Is it going to be sine or cos? Well, if I remember, when the angle is 0, it's going to be all pointing upwards. So I want a function, when I put 0 in, if you remember this trick of taking it to its extremes, if that angle wasn't 10, if that angle was 0, then all of it will be acting upwards. So I want a function, when I put in the angle of 0, I get all of it. Well, let's just recap our sine and cos graphs. That's our sine, that's our cos. Which one is a whole? When you get the angle of 0, it's going to be cos. So this red side there is going to be 900 times cos 10. So let's get the calculator out. 900 cos 10. And I've got a number of 888.9. 888.9 newtons. Let's do the same thing for the horizontal component. Well, if that was 900 cos, that's going to be 900 sine. So 900 sine 10 is going to be 140.79, so 1.0.8, 140.79, 140.8 newtons that way. Okay. This one here, our weight, is just acting downwards, so it doesn't have any horizontal component to it. So all we've got are these two forces acting. This one here is downwards 9697. This one here is upwards here, but I know that upward is actually 140.8 that way and 888.9 newtons that way. What I can do, I could add these three up now, because I've said instead of this 900, that's the same as going that way and that way. So when we have our resultant here, we're going to have a look at that resultant in terms of just its horizontal and vertical components. How long is the horizontal component of it? Well, it's the same as this length here, which is our 140.8. How much is the vertical component of it here? Well, I've gone down 697 and I've gone up 888.9. So we're going to take those two numbers away, 888.9 minus 697, And I'm going to get a number here of 191.9. Okay, so I'll just re-emphasize that. We've gone down by 697, up by 8.9. So the resultant vertically is the difference between those two numbers. So remember, we're trying to find the resultant. So I'm going to just draw that over here slightly bigger so we can see what's going on. This resultant I know is 140.8 and 191.9 newtons that way. Could you tip the sides of that? Well, yep, it's going to be a bit Pythagoras. So 191.9 squared plus 140.8 squared. Take the square root of it, and I get a number of 238.0 newtons. And then we're going to need an angle. So let's put that as our theta. And what are we going to do there? So that's going to be tan theta is opposite over adjacent. Opposite is 191.9, adjacent 140.8. So take tan to the minus 1 of 191.9 divided by 140.8. Oh, 0.8. I get a value of 59.7 degrees. Okay. Given that we start with an angle of 10 degrees to the horizontal, to the vertical, sorry, let's go back to that as well. So if that's 59, this angle here is 90. So let's add 90 to that, and we're going to get an angle of 149.7, let's call it 150 degrees. So our final answer is going to be, the force is 238 newtons at an angle of 150 degrees from vertical. Okay. Now let me, hang on a sec. Oh, no, I remembered it as 26, so it looks like I was slightly out. It was 24. I suspect I worked the ruler the wrong way, I think, originally. That's where it probably came from, or maybe I just remembered it wrong. It's quite possible. So that's the last example I want to show you, doing that exact same question, but splitting this 900 Newton force into its vertical and horizontal components, then adding those vertical and horizontal components together to get our resultant, okay, and then finding the value of that resultant with the angle. Hope that makes sense. Cheerio.